In ASAP, you can model diffuser sheets using either your own data or information from the scatter models library that comes with ASAP. Modeling diffuser sheets is a little bit more complicated than modeling other scatter surfaces because basically there are two separate surfaces to a diffuser sheet and they both have two separate sets of properties. Typically, we think of a diffuser sheet as having a glossy side and a non-glossy or a diffuse side. And if we have light incident from above the surface, say incident on the non-glossy surface, we'll have a reflected scatter that's based upon the properties of that rough surface, and we'll have a transmitted scatter that also takes into account the properties of that scatter. Conversely, if we have a ray incident on the glossy side of the surface, then the reflection will take into account the properties of the glossy side of the surface, but we'll also need to take into account the effects on the ray that gets transmitted through that surface. We can model this easily within ASAP. What we'll need to do within ASAP is actually model all four properties of the diffuser surface. We'll have to take into account a scatter modeling for the reflective diffuse side, the reflective glossy side, the transmissive diffuse side, and the transmissive glossy side. Where this gets complicated is obviously we're going to assign a set of properties to a surface, and we can't assign multiple sets of properties to any one surface. So what we will do within ASAP is use a capability that we call the search command. And we will define a set of two surfaces, one that will have the roughness properties or the non-glossy properties assigned to it, and the other will have the glossy properties assigned to it. And depending upon which of those two surfaces are struck first by an incoming ray, it can either go back through the glossy side or through, but it can't hit the surface that has the other set of properties. So for instance, if this were the glossy side, then the ray would not be incident upon a non-glossy surface. And that's done using this search command structure. And we'll see what it looks like. The first thing we'll look at is what the actual scatter functions look like for each of the surfaces in both angular and cosine space, as well as with BSDF and log BSDF. And after ASAP has integrated the information about each of the four scatter profiles, we'll look at what happens when rays are incident upon one surface or the other. The red and the blue lines represent the two surfaces of the diffuser, and the black and the yellow line are two dummy surfaces defining the direction of incidence. As we can see, the rays are coming in from one side and scattering out in the other direction. And now we'll take rays incident from the other direction. You'll notice the rays are scattering in both directions, but these rays are not interacting or being scattered by this surface. All of the rays incident from this direction are only being scattered by the surface represented by the blue line. And that's all that's required to model diffuser surfaces or any other type of complex scattering surface within ASAP.